It's a close-up.
Technologically advanced here.
Yes. All right. Welcome to Fractions.
Kristin Frang session.
Yeah. Yes. So we are not Kristin Frang, and so if you were here last time, Kristin is amazing, and we work very closely with her at the Muskegon ISD. She's the math consultant over in Muskegon, and I am Danielle Vascuo, and this is Carrie Carlson, and we are math coaches next to her, so we are part of her math team. There's the three of us, the Three Musketeers. Kristin is currently still in Denver at the Math Recovery Conference, and so she could not make it back today, so we are filling in for her. Carrie actually just got back late last night from the same conference.
And I can assure you that she's learning some awesome stuff that she will be bringing back and sharing with you as this year goes on. So
yes. So we are going to extend on the work that happened in the first session, but I know some of you did not attend the first session, and that's okay. I think if you've had any background knowledge in the fractions work or in fractions in general, the stuff that we cover today will really kind of just support and extend that. I think that's the first part. I'm going to have to come over here because I got to click through the, yeah. That's right. All right, so we're going to review our purpose here. And we are here because, and you guys can kind of read that, children's understandings of whole numbers influence how they work with fractions. And so there's a lot of misconception, I think, about how kids connect whole numbers to their work with fractions. And if they're missing that underlying understanding with whole number, they're really going to struggle when it comes to fractions because they can't make that connection. And so we're going to look at building that conceptual understanding of the meaning of a fraction. Go ahead,
and I
Carrie.
think you talked about, just nod if I'm correct, the reorganization hypothesis. Does that ring a bell? So thinking about how kids' understanding of whole numbers translates over into their understanding in fractions, right? So if they have a lack of understanding in whole numbers, or as they're learning whole numbers and it transfers over into that fraction knowledge, that's where they stay, right? And so kids look at fractions as parts and wholes. And so not necessarily understanding this idea of a fraction. And so this beginning work is how do we get kids to be able to take their work in whole numbers and transfer that over into their work in fractions. I'm pretty sure you talked about that reorganization hypothesis. So that's the work.
Yeah. So we're going to start with an inclusion activity, kind of bringing us all back together, and it's kind of laid out for you right here. I've put bins on the tables. There's sticky notes, pens, pencils if you don't have your own. And what we'd like you to do is take 2 minutes individually and kind of jot down as much as you can. Remember about the last session, or if you're new, I would say write down what you know about kids and learning fractions so that we can kind of use that to guide some discussion after that. So we're going to give you about 2 minutes. There's sticky notes on your tables, or a piece of paper is totally fine. And then I will prompt you when that 2 minutes is done for individual think time to kind of get up, and we're going to just share out some of those thoughts that we had. Last little bit that you're writing down, and what I would like you to do is find an eye contact partner. So just make eye contact with someone that you're not currently sitting with, and you're going to kind of toggle back and forth. So decide who's going to go first. Partner A, you're going to share your thoughts, and B, we're going to practice paraphrasing that. So what did they say? And then you're going to switch, and then B is going to share their thoughts, and partner A is going to paraphrase. And we'll take about 2 or 3 minutes to do that. Okay? So if you want to make eye contact with someone that you're not sitting with right now, and go ahead and share your thoughts. Okay, if you just want to stay with your partner really quickly, we're going to just kind of popcorn around the room, and if we could just have one person from each partner group kind of just share the gist maybe of your conversation, that would be great. And I'm looking right at you, so I'm going to start with you if that's okay.
Yep.
Okay.
We talked about the first assessment that they handed out last time. She gave it to her kids. I gave a different version. And just talked of that and how our students did.
I gave it as kind of a pre-assessment because we haven't even started fractions. So we'll start it probably not while we're doing decimals right now. So it kind of gave me an idea of what they're bringing from 4th grade. So.
Okay. So, and this was the assessment, one of the options that Kristin had given you last time. Yes. Okay. Next group.
Mike and I talked just about what we're noticing or what from the last session in terms of what students do bring to the idea of fractions based on what they know with homeworkers.
This front group right here?
I talked about how kids have to look at fractions 2 ways, as a whole number, but then they have to understand the numerator and denominator. And if they don't understand the denominator as a whole, they can't add, subtract, mix numbers. So it's actually a complicated piece to hold a lot of information in your head.
Mm-hmm. Good. Next, this group right here.
We talked about the 2 theories that you started with, and then that kind of led into using visuals in different ways that kids think about fractions and how we can use different visuals in the classroom to build on what they know.
Yes, I think in anything, if kids can't visualize how the math works together, it's really just very procedural for them. It's really memorization. So that's a good point. Yeah. Go. Oh, whoever was going to speak for. Okay.
I also gave the exam or the assessment to my kids as well because we were just starting fractions, and it was really cool to see what misconceptions they had about not noticing that fractions can be measurable, like measurable parts. And so we did a lot of work with like partitioning and seeing that and like breaking apart mixed numbers especially, and like seeing the holes in there and stuff like that. But I'm excited to see what we do next, so I can like go back with that again because we were just finishing up fractions and also see their growth.
So what you said does kind of lead into a lot of the work that we're going to do in the session today on looking at partitioning and then equal groups and iteration and how those things kind of play into can they use fractions as a measurement? Can they move from part whole into that measurement phase? Did I skip your group right here?
Yeah. Question. When she was here last month, she was telling us that we shouldn't use circle things such as pizza and things like that, but we can't remember the reason why.
So it is, I think it's really confusing for kids to see the circles. And Carrie, you can talk probably better about this.
When we think about the beginning part of fractions and partitioning, right? When kids partition with circles, and we say, so we're going to partition. So typically in our curriculums, in our books, the circles are already partitioned for us, right? So they don't have to think about that. They just shade in the numerator and then they say the fraction. But if I say to a child, now I want them to conceptualize partitioning, because the partitioning, when it's done for them, they don't have to think about it. So now I say, and we're just beginning this work, right? This is the foundational work of trying to build this conceptual understanding. And I ask kids to partition. And I give them a circle, and let's say I ask them to partition it into thirds. What are they going to do? Yeah. And so I think I don't know exactly what Kristin's answer is for that. My hunch is that when I'm trying to think about the idea of partitioning and iterating, and for kids to have this mental idea of a third. And when I look at a third, and if we start with this model, when kids are having to do the thinking, I have to, if I ask you to make a third, only your share, you have to be able to partition and iterate. You have to be able to think about the size of those thirds inside of this rectangle, and that 3 of them are going to make the whole. And that seems really easy. I'm telling you, it's not. When you start asking kids to do this work, young kids, older kids to do this work, that is not easy. And so when we're thinking about equal parts, and then we're thinking about kids visualizing that idea of this fraction as a measure, the circle model isn't probably the best place to start. The circle models that we're using in our curriculums are mostly done for us, right? And they're just, but do they really get, because this is what they do, so do they really get equal parts, partitioning in equal parts? So I think that's why.
So now that you probably can't use a circle eventually, like once you understand, or they understand that they have equal parts and what they mean, it's just not a good place to start, because that's exactly what they're going to do. And to them, they have made it thirds. but that's not correct. Yeah.
Does that make sense? Okay.
Next room.
I just really remember we were talking about the iteration and partitioning part of it, and how to having to kind of redesign the whole way you talk about fractions to kids and not say out of. Because when you say 1 out of 4, that's 2 whole numbers that they're thinking about and not parts of a number.
Absolutely.
So.
But that's where they're going to start, right? And and then they have to reorganize that thinking into this place of this fractions as measures kind of world. We just don't know how to get kids to that place, and our curriculums don't really get them to that place either. We jumped right to, here, color in all these, these are already divided, name these pieces, here's the numerator, here's the denominator. Now let's multiply and add fractions, but they don't really understand what they're doing with the fractions. So this work is foundational to all of the work that happens in the, beyond. All right, next.
We kind of talked about everything that had just been said.
So you have a me too?
Yeah.
Okay.
Yeah, we talked about the circle and the assessment that we were given last night.
Okay. Awesome. All right, are we back to, nope.
I think there's one more, yeah.
We talked about some of the changes that may need to be made lower down in our district so that when we go through 4th grade, so that as 4th grade teachers, we're not trying to build all of it from scratch.
Mm-hmm. So, yes. Right? So when you think about the standards in 3rd grade, do we have 3rd grade teachers in here? Okay, so this is what happened to me. I read the 3rd grade standards and I applied them to my curriculum material and my knowledge of what I had about how kids learn fractions. Once I started learning this and I reread the standards, I was like, oh, this is partitioning and iterating. This is what they're supposed to be doing in 3rd grade. And so go back and take a look, even if you are a 4th grade teacher, because we don't have enough understanding yet. This research is relatively new, and we don't even have an understanding yet as educators to the level that we need to build conceptual understanding in our students in order to really get them to understand the concepts. And so that's why we're all here, right? We're trying to figure this out so that we can have more kids be successful and understand what they're doing with fractions. So, yes.
Okay, thank you. You can go back to your seat. Okay, so if you look up here, these are the 4 outcomes that were originally built for this session, and we are going to focus on the 2 kind of yellow ones today. So gaining ideas about important experiences students need to build for strong foundational fractional reasoning, and then analyzing curriculum materials to emphasize important foundational understanding and modify those when necessary. So we're going to by the end, you're going to have an opportunity to look a little bit at the curriculum that you have, and then we're going to provide you some other resources that you can use in instructional settings that will kind of build for number 2. So our agenda for this session, we kind of just finished this reconnect with session 1, and so we're going to go into this instructional piece, and we're
actually going to continue on the reconnecting with session 1. With the video and
okay.
So that, and then we're going to move into
okay.
the games.
So the games and the adjust instructional materials, we have games for you that are broken up into 2 parts. So we have equal groups and partitioning, and then we have iteration. So we have brought some samples for you, and then you'll get a folder with copies of all of the games that you can take back that you can use and try and implement where they fit. And then we'll talk about next time and where you're going. I think Kristin will be back here next time. She hasn't mentioned that she's not. And then you'll have to do your implementation plan through the Kent ISD linked through the slides that you have from last time. You'll just have to add to that, adjust and add to it. Okay? Are there any questions about that? Okay, so Carrie's going to kind of take over now and talk to you a little bit about this bottom part of the reconnecting that will lead into the instructional piece, and she's going to give us some student examples, and we're going to kind of talk about that first.
Okay.
Okay? and I can do the computer.
Okay. Okay, so we're going to watch a video. So we're really going to think hard about continuing our understanding of partitioning and iterating. So that's kind of our reconnect with those ideas. And so we're going to watch, this is Madison. I have been working with Madison. I have lots of great video of Madison. Madison was in 4th grade. This was in October. And can you go back to that question? Did you guys read that question? Let me just make sure. What does Madison understand about fractions, and what is she trying to do? So thinking about our content from last time, let's watch Madison in action here.
Are you going to tell me just when to stop?
Yep, I am.
This is a granola bar, okay? Can you show how
Can you hear it?
people can share that equally?
Okay, go back to the...
Okay. Okay. All right, so for this first...
Is that better? Okay.
This is a granola bar, okay? Can you show how 3 people could share that equally? Okay.
So it's a long granola bar. So probably they could have 2 pieces, and then the other person has 2 pieces.
Okay, but we're sharing it with 3 people. So 3 people are sharing equally. So how would 3 people share that equally?
Or they could they could
With your marks right there, can 3 people share that equally? No, you want to flip it over and try it again? All right. How could 3 people share that granola bar equally?
get a little bite. Like say one person has a strand and then the other person, then that would be equal.
Okay, can you draw the lines of what they would, what their bites would be?
Like that.
Okay.
And then
How many bites would they get?
they would get
The struggle is real.
Do you know how many bites they get? You'd have to do it in order to find out how many bites they get.
All right, you can stop.
All right.
Okay, so talk at your table. What is Madison trying to do? And how did she phrase that other question?
Right here.
Oh yeah, what does she understand? I'm sorry, I knew there were 2 parts. So first talk about what does she understand? What, if you can find something she understands, but then what is she trying to do? Like what's her struggle? So talk about that at your tables and then we'll kind of share out a little bit. I'm just thinking. So I need to, and share out. So what does she understand? What are some things that Madison understands?
She knows everyone gets pieces.
She knows that these pieces are going to get shared, okay?
She knows that it's part of the whole.
Ah, okay. So it has to come out of the whole.
She knew they had to be equal.
Okay.
Even though the first time she did 4 equal parts, she knew that they needed to be equal, but making them equal.
Yeah, and it was interesting because she said, that's why I said to her, okay, we're sharing this with 3 people, because she said each person could get 2 pieces, right? So she had, I don't even know if she did. She
made 5
Yeah,
parts.
she had 5.
There were 5 parts, so each person could get 2, and then she got to the end and realized that this was not going to work the way that she had drawn it.
And then when I said, so if we're sharing it with 3 people, then she was like, yeah, that's, I don't have 2 for each person, so that's not going to work. So, okay, anything else that she understands? What is she trying to do?
She wanted to do 1, 1, 1. 1, 1, 1.
Yeah. Yeah. Because then the second one, she was like, everybody could have a little bite.
Right.
But then it was like for her to figure out how many little bites it was going to be, she wasn't going to be able to figure that out. Anything else?
Well, think about it. When kids share, if they have a granola bar, they're going to break a piece off. And break a piece, and then here you get the last piece.
Uh-huh.
So in her mind, when I saw that she started on the one side, and then she was flipping it around, in her mind, I wonder if she was literally breaking a piece off, and then not knowing what to do with the rest of it.
Yeah, so what is her struggle? When we think about partitioning and iterating, so think about partitioning, and I know last time you talked about 2 goals in partitioning. Do you remember what those 2 goals in partitioning were? So think about Madison, and where is she within those 2 goals? Well, first, what are those 2 goals? Does anyone remember what those 2 goals are? So I have to fair share, I have to have equal parts, and I have to exhaust the whole, right? So when she first was partitioning the one and she got 5 pieces, what happened there? What? Her parts were, she had equal-ish parts, right? But she wasn't really thinking about sharing it with 3 people and thinking about these 3 pieces that she was going to need within that whole, right?
Did she exhaust the whole?
No. Well,
Did she use the whole thing? Yeah, and when she flipped it over and they were each going to get a little part, what was she going to do? She was going to use the whole thing. She just didn't know how many little parts were going to come out of there. So out of those 2 things, she understands she's using the whole thing, that this is her whole. It's the equal parts thing that she just doesn't have down yet.
She also is struggling with iteration, right? Because she can't visualize what those pieces are going to look like to get them to be equal. So in her mind, she knows she has to share this. They have to be equal shares, but she's also struggling in that iteration piece where she can't visualize that if I have to share with 3, I'm going to need 3 of this size piece to exhaust the whole. I have another video of a girl who, when we were looking at videos to watch today, and she does this. When that same exact task, her solution was, she went like this. And I said, okay, so tell me about those pieces. And she said, well, the first person gets this one, the second person gets this one, and the third person gets this one. And I said, well, what about this one? She said, it's extra. I'll give it to my mom. There's no attention to that. In a lot of kids, they can pay attention to the equal parts or the exhausting the whole. But they can't do both of those things at the same time. And that's foundational for fraction work, right? So we have to think about that partitioning and iterating. And we did a lot of work in, can you prove it? So lots and lots of instruction. And that's what these games are here today, to have kids be working in those areas to be able to build those concepts. All right. Anything else with Madison that you noticed? Okay? All right. So now take a look at, these are the tasks from that assessment, right? So what do you notice about this task?
And this was the prompt. If the bar is 1/5, is that say 1/5 or 1/6?
1/5.
1/5, yeah. It looks like a 6 up here. Show the whole. That's what they were supposed to do. And so this is actual student work.
So thinking about partitioning and iterating, what are they trying to do? They're going to remember it more if they... All right, let's come back together. So what do they understand? What do they understand? There has to be 5 parts, okay? What else do they understand? Parts to whole. Okay? Anything else? What are they working on? Oh, go ahead.
We're saying that we could tell that, like, this one over here on the right understands partitioning. Just didn't understand the question, that it had to be, that was 1/5 of it. And the one in the middle seems like it understands iteration, but doesn't understand the whole.
Ah.
And that, the one on the left understands partition is, but does not understand that the equal parts, they have to be equal parts of that whole.
Nice.
Or they don't understand details.
Their precision is a little off,
Their
right?
precision is
Yeah.
off.
So to me, this goes back to that whole idea of this is why we don't say 1 out of 5, right? Because when they think of this right here in their head, if they're saying 1 out of 5, all of these pictures would really kind of show that, and in their brain it would make sense. And that's not what they're doing, or supposed to be doing.
And they're thinking in terms of whole numbers, right? I have to have 5. Well, successfully, they all have 5. I'm thinking of 1 of the 5. Successfully, they have shaded 1 of the 5. We're thinking that one, the one that's already done, is their one that's the one. So they didn't shade. But that fractions are about having the number of pieces shading in the numerator. That's what fractions are. That's what our materials, as teachers, that's kind of how our materials have gone about fractions as well. And so when we think about this task, they're not, when we think about iterating, they're not thinking about the size of that piece, and that piece has to be iterated 5 times in order to make that whole. They're just thinking about, I have to have 5, and I'm going to think about 1 of the 5. If I truly understood iteration in partitioning, in this case iteration, I'm going to take that piece and iterate that piece 5 times to get my whole. If my piece was that little square up at the top, if that was my original piece, I'm going to iterate that piece 5 times to make my whole. And so they're not thinking about a 1/5 as a measure that I can iterate 5 times to get my whole. It's literally, I have 5 pieces and I'm thinking of 1. But there's no thinking about the size of the piece. Anything else about that? Does that make sense? Okay. So we're going to do an activity. This is going back to, you saw this slide the last time, and was the French fry, did you get that she gave you the French fry article, right? I keep wanting to set this thing down. Yeah, so thinking about the French fry problem, and thinking about kind of this progression that we can go through, and then this was the granola bar problem. We have an activity that we're going to have you do, and it's s'mores. So the idea is that Ethan, so the directions on the top of the s'more paper, we kind of changed it up to make it be a little more than what the actual game was, to match what we want to get build in kids here. So Ethan is going camping, and they're making s'mores, and there's 1 graham cracker left, and they have to share the graham cracker amongst a certain amount of people. And so what you're going to get, are there expo markers are here. Okay, so you had this all figured out.
Okay, so you're going to work with a partner. There should be 18 of you. I think that's what I counted. And there's 10 of those. So everybody will get 1 for their partner group. And then you're going to get a spinner and an expo marker. And then you and your partner are going to take turns. You're going to spin. And then you're going to have to partition that graham cracker into that many parts. So we're pretending that, and there's 3 spinners. There's 3 different spinners. So we'll kind of have the 3 spinners going amongst these tables and amongst these tables and amongst these tables. So you and your partner are going to start playing. And let's say you have a spinner that looks like this. You spin the spinner, and that's going to tell you how many friends you have to share the graham cracker with. So if I spin a 5, I have to partition this graham cracker into 5 equal parts. My partner has to check and make sure that I'm right, that they agree that it's 5 equal parts. If me and my partner agree, I get 5 points. And you can keep track of your points on the back. Then my partner's going to spin. They get a 3.
my partner has to partition the graham cracker. Now we're going to pretend we're sharing with 3 friends. Partition into 3. And if I agree with my partner now gets 3 points. The first one to 30 wins. You have to put some sort of winner thing on it, right? But in the end, a lot of kids never even pay attention to that part. And I'm looking for, how are you partitioning as I'm walking around? So that's how the game works. But play 1 or 2 turns with this spinner. You have another spinner that looks like this. And there's another spinner that looks like this. No. This. So take a turn with each spinner and then be thinking about why the different spinners. Okay? So, and we're not going to take a really long time to play this because we want you to get into playing all those other games as well. So, why don't we do this? Why don't we have one partner? Yeah. One of you, so get with a partner, and one of you can come up and grab all your stuff. And then pass the spinners around.
Who doesn't have a partner? Somebody. I don't. Okay. Come on here.
There we go. Yeah. Okay, so these 3 spinners are going to, where are you? Over there. Those 3 spinners are going back and forth between you guys.
Do we need 2 of these though?
Nope. You and your partner only need 1 of these. You both can ride on the same one. You and your partner only need 1 of these.
Thank you.
So as you're playing this, I'm guessing. Yeah, you have to share those 3 spinners amongst this table and then just kind of pass them around.
Okay, amongst the table. So you
yes, yeah. There aren't enough for each group to have share them. Okay. Oh, here. You need it. You want to bring it home? What are these in there too? Okay. Yeah. They're in there. 4. Okay, before you get too far into this, my guess is you are probably fairly good at partitioning at this point in your life. So be thinking about your students and what are they going to do. So be thinking about your students as you're doing this. And what are you looking for as you're walking around watching this play? There should be 1 extra one.
Okay, we go right on top of it. I say that's directly on the line.
Can I have that spinner card? Just because we have a group that doesn't have it right now.
I think 6 you agree with me.
Well, I wonder if he's 2 different ways. Or if she enforces one, so it's really good.
you should switch spinners. So take one that you have not had. Switch spinners with a group next to you, one that you have not had.
Or 5.
If we're going to need some paper towel when they rotate to get a group and wipe off when they're done. So I can run.
All right, did you get a chance to see all 3 spinners? Okay, switch to your last spinner because we're not going to play this for a long time because as much as you're enjoying this, I would like you to have more things to take with you.
We found them for the right?
Oh, unless I did 8.
Oh, yeah.
They're awesome because, you can switch it out. Yeah. And it also makes some teachers all of their spinners onto these. All right, let's come back together. Finish drawing your last line.
To let me win.
Yes, I did. You know how kids do that? You play that.
Okay, so thinking about kids in this game, what do they have to start to think about? What do they have to be able to do in order to be successful in this game? And what are you looking for then as a teacher as you're walking around the room when kids are playing this game? What are you looking for? Anyone willing to share? Talk with your partner about that. What?
And then partitioning the number of
I guess they have to know these too, like, the words and the,
yeah.
and now they have to know like the denominator, not the numerator, so it's
Yeah,
pieces there are.
They'll hold the hole in their head, but they're not visualizing it.
All right, so let's come back together. What are your thoughts? What do students have to think about in order to be successful with this game? What do they have to think about? What do they have to be able to do?
They need to have equal parts.
Equal, okay.
And exhaust the whole.
Okay. Right. So this is really about partitioning, right? And they have to have equal parts and they have to be able to exhaust the whole. They have to be able to visualize this idea of the equal parts. If they're doing things like this, even in a square, they're not there yet. They're not thinking about these fourths or these 4 parts as 4 equal shares. And you will see kids who can do one, but they can't do the other. And you see kids who, when you talk about like reorganization and thinking differently, I had a student who she was trying to do thirds, and so she did, she went like this. And of course she had her extra. This is a different girl now than the second girl I was telling you about. So these are all 4th graders. And so I said to her, okay, but what about this piece? And of course she said, well, that's the extra. Well, you can't have extra. That's not, you have to use the whole thing. That's what I said to her. So she said, all right, I'll do it again. And I said, so before you do it, what are you going to think about? What are you going to do with your lines in order to get you to use the whole thing? And she said, I'm going to make them smaller. And I was like, that is not going to work. But I I was good. I kept quiet, and I said, okay, here's another strip. So she went like this. And I said, how'd that work? She said, well, I still have extra. Yep, you can't have extra. You have to use the whole granola bar. We don't want any extra granola bar. You have to use the whole thing. Would you like to try again? Yes. Gave her another strip. And I said, all right, before you draw your lines, what are you going to do? And she said, I'm going to make them close. I'm going to make them the pieces smaller. And I was like, okay, but that didn't work. But I was like, okay. So she did this. And I said, so how's that going? She said, well, this piece keeps getting bigger. Yeah, I was noticing that. Would you like to try again? Yes. Give her another strip. I said, before you draw your lines, what are you going to do? And she said, I'm going to make my pieces bigger. So this is about visualizing and really internalizing these partitions. It's not just an activity to do an activity. She had to figure this out for herself. And once we did this, she was good. She struggled when we got up into like 4 and 5 and 6 for a little while, but she was starting to make sense of what she was trying to do and reaching those 2 goals. Yeah.
I'm noticing that she continues to make 3 lines for 3 pieces. So she's hearing.
Yes, and that is also very common. You will see that very common. But we don't ask kids to do this work. This work is already done for them in our materials. So it's very different when we start to ask kids to think about partitioning and we ask kids to start thinking about iterating, because now their reasoning and their understanding really comes out. And that's the foundational piece, is this partitioning and iterating and what their thinking is. And we have to let them play games, and we have to ask questions, and we have to watch them and give them enough opportunity to be able to construct that knowledge themselves. So that was super interesting. I had to be very quiet. Okay, the spinners, real quick. What'd you notice about the spinners?
You have to be able to hold it.
No, so I'm talking about the different, yes, the clear spinners are awesome, and I'm sorry, but we're not passing those out today. But you can order those, and they are awesome. As far as the 3 different types of spinners that you played with, so on the cards, what did you notice about the different representations of the numbers that were the partitions that we were asking you to do?
One had the name of the fraction, one showed the number of the fraction, one showed the actual number of parts.
Okay.
I don't have a solid background in math or the pedagogy. I'm just curious the rationale that helps support kids with working with fractions when it just had the number, like that's how many parts. Is that intended to stretch them? Not stretch them, but I guess.
So think back to that reorganization hypothesis, right? So it's actually probably more the start. I can share with 3 people, but if I ask you to break it into thirds, that's a whole different meaning for kids.
It's more concrete, less involved.
Right, so it's going to be this progression that they can partition in 4 equal pieces. And I need them to be able to think about that first, and then I can start to think about, okay, so now what if I wanted you to just show me 1 piece? What would your piece look like? So now I have to start to think about that 1 piece, and that's very interesting too, because if I can't partition and I can't visualize those 3 pieces, I can't picture what my piece is going to look like. And so then we can start to call this that I have this 1/3. But sharing with 3 versus show me 1/3, that's a progression.
And where are kids coming from? What numbers have they been working with? Whole numbers, right? So we're connecting their movement into fractions with that whole number. That's what they're looking at. They're used to that. But now how can we use what they know to move them into the fractions? Yeah.
That makes sense?
Yeah.
Okay, anything else about the smart game? This game is in the different spinners are not the plastic one, but the copies are in your folder that you're going to get.
You have copies of these. You won't have to make these, but you just won't have the spinner piece. And then there's copies of the s'mores in your folders when you leave today. All right. So we are going to move into the games portion where you're going to have a chance to look at There's 6 games. 3 of them are iteration games, and 3 of them are equal groups, yes, exhausting the whole. Both of those things are in there. So I'm going to try and do a quick overview of each of the games. There is a direction page in with the game, but if you don't understand what it's asking you to do, don't hesitate to ask Carrie or I, and we can come over there. So the first partitioning game, this one's called Rolling for Number Lines. This is asking students, they're going to roll a die, and whatever they get, they're going to have to break their number line up into that many parts. So it's giving them a different visual, and it will connect mostly with those upper grades, I think, where they're starting to use number lines in other content areas, topics in math. So the directions are in here, and then you're given some number lines, and you can use an expo marker to go ahead and draw in there, and then I have stuff that you can wipe off when you're done. So that's the first one. This next one is parts of a fraction. So there are little bags in here with, I don't know why I'm holding this up as a microphone, but I feel like that's what it is. So this is the direction sheet, and it'll choose a card, and you're going to sketch the shape, determine what fraction of the shape is shaded, and write it under your sketch, and repeat with other cards. So this is really just getting them to practice, and then they will have the cards in here. There's a whole bunch of different ones, and they're listed right on the top page, and then you're going to repeat with other cards. So you're going to just keep practicing that. And then the next one is the granola bar. So if you're familiar with the granola bar, there's fraction strips here, and you can choose whichever size fraction strip you want. There's actually it's an energy bar, and so it goes through the description here. And then there's dice for breaking it up into parts and then cutting your one piece. So it kind of, instead of splitting it between 3, you're having 1/3, and you need to show what it was your part of that energy bar, or that granola bar. So those are the partitioning games. And then the equal groups, iteration. This one is, it's called rods and strips. So you'll see there's Cuisinart rods in here, and there's numbers, and there's a direction sheet right on top so that you can read through exactly what you're supposed to do. And then you'll need expos for this one as well to draw on the back. This one is interesting. This is called Draw It, Build It. And so this is kind of really, I think, a lengthier activity. You're going to have cards in here, these tiny little cards, and they first want you to build what it says on the cards. And you have these fraction squares or rectangles, if you've ever seen those, and they're going to pose a question like, if the brown rectangle is 1/3, how could you build the whole? And so they want you to build it with here. And then, once they've gotten that down, you're going to go to the sheet with the expo, and you're going to actually draw it. So you're going to build it first, that hands-on manipulative piece, and then you're going to draw it on here, and it'll kind of pose the same types of questions. And then the third one, I think might be one of my favorites, just because it's, and everybody will get a sheet, and you'll just have to write on this one. It's what fraction part am I? And so you have Cuisinart rods again in here, and it says the size of the part is 1 red rod, the size of the whole is a purple rod. So then you have to name the fraction. So what is the red rod of the purple rod? And then it actually just kind of justify it, or you can have kids explain what they know about that. How do you know that that's that part or that fraction? All right, so what we're going to do is we're going to have you kind of split up into 2 sides, 2 groups, and we're going to give you a chunk of time to play with just whichever group you're in, whether it's the partitioning games or the iteration games, and then about halfway through, probably about 10 minutes, we'll just have you switch sides of the room, and then you'll get to try new games. And you're going to go home with all of these anyways, but at least it gives you an opportunity to practice and kind of talk about them with your partners and whoever you choose to work with. What questions do you have about this next part of our session? Okay. So I'm going to go ahead and I'm going to put, we'll put the equal groups and exhausting the whole partitioning games over here, and you can kind of spread out, take a bag. There should be enough for multiple people to do each game. There should be 3 copies in each baggie, so you don't just get one. You can, do the same as the people next to you if you want to. And then I'll put the iteration games over here.
As you're playing, think back to the French fry problem and think about the A task in that promote the partitioning as exhausting the whole and making equal shares. And as you're playing those games, think about those games that will promote that goal. Think about the games that are actually promoting iteration and that piece of understanding those connected copies, and then the iteration with the larger number of shares. So as you're playing the games, you want to be thinking about those pieces and where these games fit in. Okay, want to share what you were talking about? Let's maybe share out in tables or however you were talking, just something that you were talking about, something you were thinking about differently. Based on the knowledge that you have gained in fractions in the last 2 sessions. So is there somebody willing to start? Thank you.
I really like to build it. We were just saying that, in our math curriculum, everything is drawn for you. And you do not get this is 2/3, what does a whole look like? And, we were whipping through those cards, and then all of a sudden we got to that one that was, the yellow represents 2/3, what is a whole? We're like, oh, wait a minute. So we had to, divide it. Wait a minute, we're multiplying and dividing without even realizing it. Mm-hmm. And to teach our kids how to do that with models, like things that they can touch, and then bridge the gap to that algorithm, I think would make much more meaning for them. Mm-hmm. Because so often we're just like, okay, here's the test, you have to multiply and divide this way, and that's your answer.
We had 4th graders last year that were doing, it was a half and 3/4. And we had been doing all this work, but we had really worked on this conceptual piece. And one kid said, well, it's going to be 1 and 1/4. And I was like, how'd you do that? And he said, because if you have 3/4, or if you have 3/4, you have a half in there, and a half is a whole, and then you have this other fourth. And I was like, can you draw me a picture of that? And they're like, yeah, sure. But I mean, they were truly thinking of fractions as numbers, not as, fractions as measures. They were using the fraction as a number, and not just thinking about parts and wholes.
And think about how much that builds their reasoning ability. Instead of it's just procedural, they are reasoning now, and they're using the reasoning to get to the answer, and they're not trying to memorize an algorithm or a procedure or steps, because they can reason through what this actually means.
Anyone else want to share what they were talking about? Or what ahas or things you were thinking?
I know that we use everyday mathematics in our district, and it's all circles.
Oh.
That's what they give you in the back of the book for the kids to punch out and to use as they're manipulative. So I know for me it's going to be having to recreate. Yeah.
Can you think about doing, and I don't know your material well enough to know this, but think about the tasks and the activities that they're having kids do, and just give them strips instead of.
And that's what I'm thinking.
So that there's not, because we don't have time.
Yeah, not recreate, but use the lesson.
Use it in a different way.
I see manipulative
okay.
to hopefully do it, and hopefully not everything that they have to do in their book or anything is all circles. It might be, we're going to do.
Yeah.
Because my first year using this curriculum, I mean, they do have number lines, so there's one little thing there.
Yeah.
And it's hard to find number lines that don't already have tick marks in them.
Yep.
Yeah.
So make them.
Yeah. Anyone else? Yeah.
Well, so I do 5th grade. We do everyday math too, and I recreate a lot.
Yeah.
But I do, for my 5th grade, we're talking right now about division and then thinking of a remainder as a fraction. So students sometimes struggle with where they'll put a whole number, and they can divide using the whole number, but then when they get to the remainder, they struggle with how do we split that up, or how do we know when you can split something up into a fraction, or how much.
Mm-hmm. It's abstract.
Yeah, so we kind of have to go back to that kind of, we went back to those squares and strips to kind of.
Yeah, so bringing in the concrete model so they can visualize what's happening, then I can attach numbers to the work that we're doing concretely. Now the numbers make sense because it just matches what I'm already doing. When I try to teach abstractly, I have no idea what you're talking about. I'm just going to try to follow your rules, hope for the best. Anyone else? All right.
So this was just a quick reflection. We're not going to we're not going to have you stand and share, but what might you feel more capable of transferring back to your diverse community of students as a result of this afternoon's learning? And we kind of just talked about that a little bit. You talked in your groups too, when adjusting your research this new stuff, these kind of new ideas, and then transfer it back to what you have in front of you, because you can't recreate everything, but how could you adjust it just a little bit? And so we appreciate you sharing out and sharing with each other, because I'm sure that you got ideas from other people here today that you wouldn't have thought of. So we are now going to give you time to go into Google Classroom and do your the implementation plan and the implementation guide. Reviewing your commitment, stating your intention, and then you'll need to, prior to next session, submit some evidence through Google Classroom.
Does that make sense to you all?
Yep. Okay. And then you can talk in your groups about these things, reflecting on these questions, what might be some things that are vital to communicate back to your building mathematics team and to your school based on learning today. And then, of course, you're going to go to the bit.ly